All right, I think we're live. Looks like it. All right, everybody, welcome to day number 9 of the Advent of Cyber. Today is going to be called Malware Analysis. She sells C# shells by the C2shore. Let's go ahead and jump into it. I've already gone ahead and fired up the machine, but let's continue on with the story here. Ooh, that's I'll switches over to dark mode. There we go. That's prettier. All right, having retrieved the deleted version of the malware that allows Tracy McGreedy to control elves remotely, Forensic McBlue and his team have started investigating to stop the mind control incident. They are now planning to take revenge by analyzing the C2's back-end infrastructure based on the malware's source code. All right. So it looks like we're going to do some reverse engineering of this malware to find out what it is. So today's objects are going to be, in this task, we will focus on the following vital learning to assist Forensic McBlue to analyze and retrieve malware: the foundations of analyzing malware samples safely, the fundamentals of .NET binaries, the DNS or DN spy tool for compiling malware samples written in .NET, and building an essential methodology for analyzing malware source code. All right, malware handling 101. Important warning: handling a malware sample is very dangerous. They need to put the word very, not just dangerous. Always make sure you're taking any precautions during your analysis. As mentioned, handling malware is dangerous because it is software explicitly designed to cause harm, steal information, and or compromise the security and functionality of a computer system. Given this, we will again introduce the concept of malware sandboxing. A sandbox is like a pretend computer setup that acts like a real one. It's a safe place for experts to test malware and to see how it behaves without any danger. Having a sandbox environment is essential when conducting malware analysis because it stops experts from running malware on their actual computers, which could be risky and harmful. The last thing you want to do is throw up malware on your computer, especially a work computer, and get it on that network. Not good. A typical environment setup of malware sandbox contains the following: network controls. Sandboxes often have network controls to limit and monitor the network traffic of the malware, the network traffic that the malware generates. This also prevents the propagation of the malware in any other assets, meaning that computer is put in its own little environment. Virtualization. Many sandboxes use the techniques of VMware, VirtualBox, and or Hyper-V to run the malware in a controlled, isolated environment. This allows an easy snapshot, reset, or disposal of that after the analysis. And of course, you want to monitor and log. So monitor and logging. Sandboxes record detailed logs of the malware activities, including system interactions, network traffic, and file modification. These logs are invaluable for analyzing and understanding the malware's behavior. We've already connected to the machine. We've got that over here on the right side. So optional, building from the VM day 1. Right, optional, building from the VM on day 8. You can use the password Advent of Cyber 23 on day 9 to unlock the zip archive. Oh, you can just use what was it. Okay, we've already got this in here. So let's have a introduction to .NET compiled binaries. .NET binaries are compiled files containing code written in languages compatible with the .NET framework, such as C#, VB, VBNet, F#, and managed C++. These binaries are executable files with the .exe extension or dynamic link libraries, DLLs. They can also be assemblies that contain multiple types of resources, or multiple types and resources. Compared to other programming languages, C and C++, languages that are used like .NET, such as C#, don't directly translate the code into machine code after being compiled. Instead, they use an intermediary language, or IL, like a pseudocode, and translate it into native machine code during runtime via the common language runtime. So basically what they're saying is we've got different types of languages. So we've got like Python, we've got C#, VB.NET, F#, managed C++. All of those are high level softwares that are used. And then we've got stuff like assembly, and I believe C is way down there that can actually interact with the machine. So you've got .NET in the middle of there, and in the middle of that, it's like a decoder that talks down to that to the computer directly to allow it. So it translates from that top level down to that bottom level is what those intermediaries are doing. This may be a bit overwhelming. In simple terms, it's only possible to analyze a C or C++ compiled binary by reading its assembly instructions low level. Meanwhile, a C# binary can be decompiled and its source code retrieved, since the intermediate language contains metadata that can be reconverted so it can be reconverted to its source code form. Let me move this. Got a pad I'm standing on, keeps getting underneath me. All right, C# programming. Based on the elves' initial checks, it has been discovered that the retrieved malware is written in C#. So let's quickly discuss C#'s code syntax and analyze sample effectively. Note, you can skip this section if you're already familiar. Well, we're not familiar. We're starters. We're newbies. So let's check this out. What are some code snippets? So we've got namespaces, classes, functions, and variables. For this section, let's use this code snippet. So we've got namespace, demo only, internal class, basic programming, static, void, main, string with args or arguments. The string to print is going to be hello world. Show that output to print. Public static void show output string text. It's all Greek, right? So let's kind of break this down. Code syntax: namespace, a container that organizes related code elements such as classes into a logical grouping. It helps prevent naming conflicts and provide structure to the code. In this example, the namespace demo only is the namespace that contains the basic programming class. All right, so what's a class? Class defines the structure and the behavior through functions and or methods of the objects it contains. So it defines the structure and the behavior of the objects it contains. In this example, basic programming is a class that includes the main function and the show output function. Moreover, the main function is the program's entry point where the program starts its execution. And then we've got function, a reusable block. So a function is something you can write a function and then continue to use it throughout just by calling that specific function. So we could say our function is to write hello world, and throughout our code we can put that function anywhere we want to, and it'll go back to that function and just print out the hello world if we have that. See how they say it. A reusable block of code that can perform a specific task or action. In this example, we have show output. The show output function, it takes a string through the text argument as an input and uses it on console.writtenLine to print it out, to print its output. Note, the show output function only receives one argument based on how it is written. Okay, so we got the fourth one, there's a variable, a name storage location that can hold data such as numbers, integer strings, text. or objects. In this example, toPrint is a variable that handles the text hello world. All right. Then we've got loops. We've kind of gone through loops, or we've kind of gone through this first step. We've kind of done already some of this stuff in some of the previous days. This is kind of getting more into the nitty-gritty of everything. So we've got for loops. A for loop is a controlled structure used to repeatedly execute a block of code. So basically within there, if this is true, then continue to do this. If it's not, then do this. But a for loop just constantly, let's just loop. So for initialization, condition, and iteration, and this says for integer I equals 1. If I is less than or equal to 5, add 2 to it, I believe. Console written out I love McSkitty. So in this example, the loop is initialized with 1 and stored as a variable. It checks the variable I. If it's less than or equal to 5, it'll increment itself 1 time up. So it adds 1 to itself for every loop iteration. So in simple terms, this code snippet means that it will call console.writtenLine function 5 times, since the loop will count from 1 to 5. Loops can be immediately terminated using the code break. All right. Conditional statements. Conditional statements like if and else are control flow statements used for conditional code execution. They allow you to control the code block should an executed base should be hold on. They allow you to control which block should be executed based on the specific condition. All right. So based on the example above, the if statement checks whether the number variable contains a number greater than 5 and prints the string. The number is greater than 5. If the condition is not satisfied, it will go to the else statement, which prints the number is less than 5 or equal to 5. Essentially, it will go to the code block of if statement, and if that number variable is 7, and it will go to the else code block if the number is set to 4, because it hasn't hit 5 yet. All right, so importing modules. C# uses the using directive to include namespaces and access classes and functions from external libraries. Using system, after importing, we can now use all of these classes and functions available in the system namespace. The code snippet above loads an external namespace called system. This means that the code can now use everything inside the system namespace. Okay. Don't worry if you find these code snippets a little overwhelming. Once we start analyzing the malware, the following sections will be much easier to understand. All right. C2 primer. This is quick. We won't read all of this, but we can quickly look at the infographic here. C2 primer is a command to control server. Basically, what it's doing is an agent is put on a machine. An adversary or attacker threat person will put an agent or something on a machine, get into that machine and put that on there. And then what that does is beacon out or ping out to the C2 server that we've got. We got over here. Lost my mouse. So we've got the C2. We've got a C2 server here. And basically what this is doing is it's got its the agent is put on this computer, and it wrong way. It is going here, and then when we see our arrows, we're going here. It talks to the C2 server. The attacker can sit over here and add stuff or remove stuff to the C2 server, and once this agent reaches out to the C2 server, it can send information back. So it can say, hey, I want you to run this code at this specific time. I want you to not do anything until this time happens, or I want you to go ahead and encrypt everything and fire off the shell command that says, hey, look, your computer is now infected. Whatever it is. Whatever the attacker is wanting to happen. That's a quick, dirty overview of a C2 server instead of reading all of this. All right, decompiling malware samples with dnspy. And now that we've tackled the theoretical concepts to build our technical skills, let's start playing with fire. Uh-oh. Got our malware. Since we already assumed that the malware sample is written in C#, we will use the dnspy to decompile the binary and review its source code. dnspy is an open source .NET assembly, C# debugger, and editor. It's typically used for reverse engineering .NET applications and analyzing their code, and is primarily designed for examining and modifying .NET assemblies in a user-friendly, interactive way. It's also capable of modifying the retrieved source code, setting up breakpoints, or running through the code one step at a time, aka debugging. All right. To proceed, let's say note, as mentioned above, we won't execute the malware, so the debugging functionality will not be discussed as following. So to proceed, let's go to the virtual machine and start the DNS spy tool by double-clicking the shortcut. All right, here we go. Double-click. Once the tool is open, we will load the malware sample by navigating to File, Open, located in the upper left-hand corner of the application. Now that we got that open, File, Open. When you get the prompt, click on the following navigation, go to desktop artifacts, so desktop. Oh, there it is. Artifacts. Now that you're inside the malware sample folder, you first need to change the file type to all files. Gotcha. There's our artifacts. To see the defanged version of the binary, now double click the malware sample to load it. So now we're loaded. Let's drop this down. This is our malware here. And this is going to be our run library. Ooh, there's a lot of stuff in there. All right, once the malware sample is loaded, you'll have the view like an image below, and the next step is to click the main string, which will take you to the entry point of the application. Ooh, decompiled. Nope, now we've opened up the program. And now we can see what we've got here. Looks like we got a decryptor, encryptor, execute command, get it, implant, main, post it, sleeper. These all look like functions. All right, as discussed in the previous section, the main function in a class. Main function in a class is the program's entry point. That means that once the application is executed, these lines of code inside this function will be run one step at a time until the end of the code block is done. However, we won't be dealing with this function yet, since reviewing it without understanding the other functions embedded in the malware code could be a bit confusing. All right, so let's start going through here. All right, understanding the malware. You might have been a little overwhelmed when you saw the main function, but don't worry. We'll discuss the other functions before building the main execution pipeline. Focusing on individual functions before dealing with main function can be considered a modular approach. Doing this allows us to easily break down the malware's functionalities without getting bogged down with long code snippets. Moreover, it allows us to recognize some potential execution patterns that ease our overall understanding of the malware. To start with, view the list of functions inside the program class by clicking on each highlighted section as shown in the image below. Here we got program. Nothing in the program. Decryptor, looks like we got decryptor, encryptor. Look at this, we got you can hack this super. You can't hack this super secure 2 keys. All right. Is that in both of those? Yep, that's in both of those. All right, let's scroll through here. After clicking, you will see the functions in the drop-down menu. Let's run through them individually better to understand each code's meaning. You can click on the items as we discuss them to compare the code in DN Spy. It's also advisable to read the .NET Framework documentation to learn more about the internal functions mentioned in the following sections. We don't have time to read that tonight. All right, get it. So let's move to the get it function. Our get it function, we can look in here. It looks like it's a web request, HTTP web request. Create URL. Looks like it's got a user agent and wants to make it look like they're using Mozilla or they're using Firefox. On a Mac machine. So far, okay. Based on the sort of the get it function uses the web request class from the system.net. We see a system.net in here. From the system.net namespace and is where do we see that system.net namespace? I don't see that in here. I guess it's probably going to be up in the program. Class. All right. That's get it. So based on the source code, the get it function uses the web class from the system.net namespace and is initialized by the function's URL argument. The name is already a giveaway with the web request is being used to initiate HTTP request to remote URL. All right, we've got HTTP web request, create URL, user agent. I don't see class in here. I think we're a little too deep on that one. All right, go back to get it. You can render the namespace details by hovering over the web request string. Oh. There we go. Okay, so when we go over HTTP and web response, then we get that. Okay. By default, the HTTP method set to web request class is get. This means we can assume that the HTTP request made by the function is to get the request, meaning we're going out to a website. We're looking for a website. We're reaching out to grab information. Stuff isn't being sent to us. By default, the HTTP method set to the web request class is get. That means we can assume we're at that. The 3 lines of code inside the function can be expanded by the comments written. Okay, we already looked at the code. In other words, the getIt function accepts a URL as the argument, configures the parameter needed for the HTTP request, custom user agent, and returns the value of the response. All right, post it. I got a feeling that's going to be sending information. Well, let's see. It's a post method. Like the getIt function, the post function also uses the web request class. However, you might observe that it has configured more properties than the first one. The most notable is the method property. There we go, method property. Wherein the value is set to post. This means that the HTTP request made by the function is a post request, and it submits the second argument as a post data. All right. 3 is sleeper. The sleeper function contains a single line, a call to the thread sleep function. The thread sleep function accepts the integer as an argument and makes the program. So let's see, sleep. So all we've got here is a thread to sleep, and then they're going to throw count in, and it's going to the count parameter. And if we look at sleeps got millisecond timeout, so whatever that count is going to be in milliseconds. So if we put 1,000 milliseconds, it's going to be 1 second. So for every 1,000 milliseconds will be 1 second. That's all that is. So this is going to be sleeping or setting the program to not do anything during this time. The execute command, given the namespace, let's see, I'm going to assume that's executing it. Given the namespace of the class system.diagnostics.process of the initialized process class, first code line. Let's see, it seems this function is being used to spawn a process according to its Microsoft documentation from the initialization of the process start info property. We can also see that the file to be executed is cmd.exe. So it's going to open up a command prompt or run whatever it is through a command prompt. That the execution command's argument is being passed by, okay. In short, the code snippet results in cmd.exe running the command /c and then command variable. Let's see. And then whatever the command is that is being sent to it. Okay. Another thing to note is that the Windows style property is set to process Windows style hidden. Wow, interesting. Where's that at? Process hidden. There it is. Windows style hidden. Basically wants to run it in the background. It's going to run this stuff, but it's not going to bring it up on the screen to actually show you that it's running. So it's going to be hidden in the background. I went too far. All right, there we go. Encryptor. Note, we won't be diving deep into cryptography, so we will skip discussing the imported functions used to encrypt. The giveaway in this function are AES classes used in the middle of the code block. If you, however, man, can't talk. Can't read, can't talk tonight. If you hover on the initialize of AES managed variable, it also shows the namespace system.security.cryptography, which somehow means that everything here is related to cryptography or encryption, which we're on encryptor. There you go, encryption. If we hover over AES managed, there it is. You see system.security.cryptography.AES managed. Okay. Moreover, the encryptor function accepts an argument and encrypts it using a hard-coded key and IV values. And lastly, it encodes the encrypted bytes into base 64 using convert to base 64 string function. In summary, the function encrypts a plain text string using AES cipher together with the key value and IV value. And returns the encoded base 64 value of the encrypted versions of the string. I'm going to assume the decryptor does the exact opposite. It decrypts everything. Decryptor, you won't be using this. This function is the opposite of the encryptor. There you go. So implant, we got implant. Implant is the last function. It accepts a URL string as an argument, initiates the HTTP request to the URL argument, and decodes it with base 64. It also retrieves the app data path and attempts to write the contents of the base 64 decoded data into a file. Lastly, if the implanted file was written successfully, it returns its location. If not, it returns an empty string. Let's look at this real quick. So convert from base 64, get URL, string, environment, get folder path. Looks like it's going to set up spykit.exe, file write all bytes, text bytes, if file exists. So if the file exists, then return the text, otherwise return nothing. All right, building malware execution pipeline. And now that we have analyzed the other functions of the malware sample, we will return to the main function. In muting the vein. Where's, oh, main. Here we go. Looking at the wrong thing. Here we go. Okay. Again, viewing the main function source code is a bit overwhelming since its code block contains over 60 lines. 60 lines is not a big program. Come on. To make things simple, let's try to split the analysis into 3. Code execution before the loop. So we got private static void main. Okay, private static. So this part right here, code execution before the code. The first code section before the loop executes the following. So it retrieves the victim's machine's host via dns.getHostName function and stores it in a variable. So getHostName. So we're creating variables like we did a couple days ago, where we were writing Python. Remember, we were writing Python and we were creating variables. So in here, we're going to create the variable host name, and we're going to give it the value of whatever machine it's on. So it's going to use dns.getHostName to pull the host name of the computer, whatever the computer's name is. That's going to be in host name. Looks like it's going to create a string value of McGreedy secret2.thm, which is the bad URL that we got a couple of days ago as well. Initialize HTTP. That's our C2 domain, right? So that's our command and control domain is what it looks like. 3, execution of HTTP post request to the target URL together with the post data that contains the host name and the victim machine. So we're going to write a string to the URL with the registration with the name of the host. There's our data, the name plus host. And then initialization of other variables which will be used in the following lines of code. We got integer, which is a count of 15,000, and then a Boolean flag of false. And I'm going to assume that this count 15,000 is probably going to be the count that we're going to be using for what we looked at in the sleeper. 15,000 would mean that that's going to be sleeping for 15 seconds. And then we've got a Boolean flag of false, and I'm not sure what we're going to use that for. So let's see. As you can see, most of the lines in this section are all about initializing values in variables. However, there are 2 notable functions. The DNS get host. So we call that function retrieves the victim's computer name or the host name to attempt to distinguish the compromised machines, which makes sense, right? Because if we have a C2 server and we're sending our malware out to hundreds of thousands or hundreds of millions of computers and we get them back, we want to know what the machine's called. We want to know where it's coming from, right? We don't just want to give everything the same name. We don't want computer 1, computer 1, computer 1. We'd want 1, 2, 3, 1 right names. Okay. We have already discussed the post-it function, and we know that it makes a post request to the URL, first argument, and submits the host name as post data to the second argument. All right. In this initial step, it seems that the malware reports the host name of the compromised machine first to establish the C2 connection before executing the other functionalities. All right, code inside the loop. So now 4. Now we've got a loop here. In this section, you'll see that the loop is written without any initialization values on the initialization condition or increment section. So we have a 4. This means that the loop will run indefinitely until we actually make it break. So this is probably just going to be something that's going to constantly run. Let's scroll this down a little bit. All right, afterwards, the first line of the loop block block uses the sleeper function where it uses the count variable. So remember, there it is. We have a count variable of 15,000. So our program, we're gonna run the sleeper command. We're gonna hold off 15,000 milliseconds. So what this is gonna do? Wait 15 seconds and it's gonna run, and it's probably gonna run all the way through. And once it gets done, guess what it's gonna do? Loop back, and it's gonna hold off for 15 seconds. That's a way for us to stop the program from running and to slow down what's going on the network. As a network administrator, if you get on the network and you start seeing just something constantly firing off, boom, 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 and you see this computer constantly hitting this, it's a flag. So you can go out and put this out there. This is really fast, 15 seconds, but you can put stuff out there every hour, every 60 minutes, every 4 hours to reach out and touch it. Every 8 hours, reach out and touch it. Do it in off hours, things like that. So that's what this is set up to do. Where in this function count variable is being passed, remember that this variable was already initialized in the loop above. The following code lines are variable initializations wherein these string and string2 variables are used. If the value of the string is http evil.com and the value is set to string2 is test, the result of the URL variable evil.com/tasks. Tasks. Oh, evil.com/tasks/test. Where'd they get task from? Evil.com. Do we have tasks in here? Oh, yeah. There we go. Right here. Tasks. So if it's URL2, it's going to be string. So we'll have evil.com/task/whatever string variable 2 is. Do we have a string variable 2? There it is. The program. So string 1 and string 2. Eventually, the URL2 variable is used by the getIt function to do a GET request to pass the URL, and the result is stored in the IT variable. There it is, IT variable. Lastly, the execution flow will enter the if statement only if the IT variable is not empty. You may review the detailed annotations in the code snippet below. We won't do that. In summary, the section is focused on the preparation of the variables and executing the HTTP GET request to the tasks endpoint and enters the if statement code block once the condition has been satisfied. All right, code execution. Code execution within the first if statement. Continuing the execution flow, this code block will only be reached if the GET request on the task's endpoint contains a value. All right. So this whole, what are we saying? Oh, where'd my mouse go? We're saying if I believe it's this one right here. It is no. Yeah, we're saying this whole block. Whoop, let's clear that off. We're saying this whole block here. All right, so we got if all the way through. This whole block here will only run if that task's point has a value. The section before the if, so section before here, so where's our if sleep? The section before the if sleep here. Statement is focused on initializing the variables A and text. It starts by decrypting the string stored in the IT variable and splits it into space with space characters. Decryptor IT split. The A variable values is the first element of using the resulting array, and the text variable combines all elements in the same array, excluding the first element. The example below shows the IT variable, how the IT variable is being processed. So we'll scroll down looking through here. So step 1, split the decryption string with the space. So we did this yesterday, I believe, when we were writing our, when we were going through, which task was that? I think it was day 7 or day 8. When we were splitting up and we were looking through all of the all the logs, right? So we were writing specific entries to split stuff up within our logs. This is the exact same thing here. We're going to split this information that we have up. So split that decryptor, array, decryptor, split at wherever a space is. Shellnet local group administrator split. Step 2, store the first element into the A variable. Step 3, combine the remaining elements, excluding the first, using space if array, length 1, then text. It's kind of going through and just explaining every single step of this code. Next step, conditional statements. We can continue on through all of this. So let's kind of break this down. The contents of each conditional statement within this code here, we have the sleep function, right? So that sets the value, the value of that is set by using the count variable, which is being used in the sleeper function, right? We've got shell, and the shell function or the shell area in here is going to be using the execute command to run the OS commands with the text variable. It encrypts the command execution output using the encryptor function, and it reports the encryption string to the C2 server using the posted function via the results, so the URL3, using that results endpoint. To implant, that's going to execute the implant function with the redacted domain. It's going to encrypt the output of the implant function via the encryptor function itself. Then we're going to reports the encrypted string to the C2 server using the posted function via the results endpoint again. And quit sets the flag variable to true. So up here before we had the Boolean flag set to false, meaning just keep running. And then once we actually get through this and we actually have all this information here, once we actually get through here and do this, now our flag sets to true. If any of this doesn't work, if any of those if statements don't work, it will hop out of that and continue on, and we'll continue to run until we get that, till we get true. See if there's anything in here we need to really go through. Remember that the A variable value is based on the response received after making an HTTP request on the task. This means that every condition in the code block is based on the instructions pulled from the endpoint. Hence, it can be said that the task URL is the endpoint used by the malware to pull C2 commands issued by the attacker. Moreover, the implant and shell command responses are submitted as post request to the URL3 variable. Remember that the variable handles the results endpoint. All command execution and implant outputs are reported to the C2 server. This may be a little overwhelming. All that. Breaking the loop. Lastly, the final condition statement at the end checks if the flag variable is set to true. If that statement is satisfied, it will execute a break. So basically stops, terminates. This means that the if statement contains... All right, so we've looked through all of this. Now let's go ahead and see if we can answer these questions and find this. All right, what HTTP user agent was used by the malware for its connection? So we looked at that before, right? So I think we had, was it in get it? There we go, get it. So here's our user agent. So we've got the Mozilla. That's our user agent. Copy. That should be it. All right. What is the HTTP method used to submit the command execution outpost? So what is the HTTP method used to submit the command execution? Oh, the execute our method. The methods we looked at were post. Where were they at? Then post. Yeah, method. There it is. Post. POST. All right. What key is used by the malware to encrypt or decrypt? We saw that before on the encrypt and decrypt. Got that. What is the first HTTP URL used by the malware? All right, so we're going to need to come back down to the main. And our first HTTP URL is going to be that's it, and then dash the very first URL. I believe it's reg. Should be right? Yep, there we go. So that's our very first URL and string. So remember, this is our string. This is how we get this. Our string is here, and then our URL, that's going to be attached to the end of that. All right. How many seconds is hard-coded? We saw that earlier in here. There's 15,000, but remember, we're milliseconds. So that would be 15 seconds. What C2 command? What is the C2 command the attacker used to execute command dot or command via dot exe? What's the command? Oh, so here we have our sleep command, we have our shell command, our implant command, and then our shell is what we actually use to run the execution. So we've got shell. All right. What is the domain used by the malware to download another binary? I think we're just wanting the domain here. That doesn't look right. Format is that . Oh, here we go. This is to download. So here's our implant. Here's our domain. stash.mccready.thm. That is going to be our domain that we're reaching out to download other binaries once we've actually established connection. And there we go. And that's all of our answers for day 9 of Advent of Cyber 2023. Check out the malware analysis module in the SOC level 2 path if you enjoyed analyzing malware. That was actually pretty fun. There's a lot in this. We did skip some of this stuff in here because it is long. There's a lot of reading in here. I'd suggest everybody go back through. We've got our answers, but go back through, read that, and actually understand what it is that we did in here. All right, so that'll wrap it up for today. See you guys tomorrow. Until then, have a good one.